Well, hello. I would like to do the notes for 1.3 variables on both sides. So we have been doing these notes here for some time, but adding slowly but surely one step at a time here. And so I want to go ahead and wrap up all of the steps and put it all together. It's kind of like doing a whole dance move and getting things going on here. So I want to refresh your memory that first of all, okay, we have all of the simplified steps. So the simplified steps are steps where we are simplifying or making as simple as possible the left side of each equation and the right side of each equation. And so that includes drawing the river, which is really not even a simplify, except it's just drawing your eyes to the separate sides of the equation, eliminate parentheses using distributive property, and add like terms. So then from there, we are going to add the steps where we're solving. Okay, and for the solving, what we're going to do is we are going to, so I'm going to highlight this, get all the variables to one side, and that is the new step today. Get all of the constants to the other side. Notice to one side and then the other. That implies that they're going different directions, and then get x alone. And so we're going to use this plan and be very specific about going through each step because that is going to make the difference. So I'm going to go ahead and do that here and go through each step here. So I'm going to draw the river, and that just shows me what's on the left side and on the right side. So I look on this side, so next step, no parentheses. So I look on this side, oh, yep, I have parentheses. So now I'm going to do that step. And as I do that step, I'm going to go ahead and rewrite. And it's a lot of rewrite. And there will be a point when you get so good at this that you won't need to rewrite every step of the way. But that is what we're going to do for now until we can force your thinking, until you can force your thinking into following these steps every time. So I'm going to go ahead and distribute because I have these parentheses. So I want to eliminate these parentheses by distributing, which is a process of multiplication. So 7 times 6y is 42y plus 7 times 12, 7 times 2, which is 14, and then plus 4y. So you notice the 4y is just kind of out there on its own. It's just hanging out, so it's not part of the parentheses. It's got a plus sign there, so we're just bringing that down. So we've got that step done. So we now look at the next thing. We need to add like terms. So I look at the left side. There are no like terms. I have a y term, I have a constant term, but they're not like. So we're not going to do anything with that. So now I look at this side and I notice that I have a y term and a y term. So I'm going to combine like terms. And so again, every step of the way, I'm going to go ahead and rewrite the problem, which means that do not be afraid to take up a lot of real estate on these problems. All right, so always have to be careful with the signs. In this particular case, we got lucky, everything's positive. So I've got 42y plus 4y, and that is going to be 46y plus 14. Okay, so I've got 46y plus 14. So I've done everything I can. I look at this side, there's a y and a constant. I look at this side, and there's a y and a constant. So that means that I'm ready to move on to the next step, which is solve. And notice it says I need to cross, I can cross the river now. Okay, so I'm a little bit strategic, and I shared this yesterday. My first thing is to get the variables to one side, and I'm a little bit strategic about this. So I'm looking, I don't have y alone already on one side. What I do have are 46 positive y's on the right, and I have 6 negative y's on the left. And I know that if I move these 6 negative y's to the right, plus 6y, and we're doing inverse operation because we're crossing the river, that I'm going to end up with this overly positive number. And that makes me happy. I like positive numbers in front of my y. So that's going to be 52y. I'm seeing a big number here. So now, because I went to the right with the variable, I'm going to go to the left with the constant, going to the left with the constant. I kind of sound like that guy on Khan Academy. when he keeps repeating himself. So minus 14. So when I do that math, so 430 minus 10 is 420 minus 4 is 416. It's still positive though, equals 52y. Now I look at that and I say, Google, where are you? How many times does this go? So I'm going to guess, okay? I'm going to guess. So 52 times 8. 8 times 2 is 16. 8 times 5 is 40, 41. Look at that magic. I am magic. So y equals 8. Because, and how did I know that? Why did I know? Because let's get more math, and I'm pretty sure, especially the way I set it up, I'm pretty sure that it's going to be a whole number. And it's probably not a very big whole number because 10 times 52 is 520, so it's got to be less than 10. And I know 2 times 8 ends in 6, and this ends in 6. So I just guessed, honestly. I didn't guess in the end. I actually did the math, but I guessed to see kind of where I should start, and the 8 worked. All right, so y equals 8, and I'm done. That's it. Now you say to yourself, that's it. You're so funny. I mean, really, it is a lot, so don't get intimidated by this. If you see it enough times, you do it enough times, I think you're going to get it. Okay, so let's go ahead and go down to this next one. We got some problems that look a little bit different, some a little bit easier. Okay, so we're going to go do these problems here. All right, so I look at this problem and I'm going to go through the steps. So the steps mean that I need to draw the river. Draw the river. Okay, so then I need to do my parentheses. Nope, done. I need to do my add like terms. I look at this side, no like terms, no like terms. So no like terms, that's done. Oh, that means I get to cross the river. So I get the variables to one side. Notice I put a little arrow there. It doesn't have to go that way, it's just a symbol. But in this case, it is going to go that way. Why? Because I've already got x established alone on that side. Just easier. So minus 2x, minus 2x. But what it requires is for you to be careful with this. I have a negative 3 and a negative 2, and it is going to be negative 5x. And that's going to equal 19. Now, this stuff is out of Big Ideas Math. Big Ideas Math is not as afraid of fractions as Get More Math. Actually, Get More Math has a lot of fractions. It's just, what do I assign you? And so in this particular case, I'm going to do the next step. So I did the variable to that side. Notice what I do with the constant here. I'm going to the other side. So these are my symbols to kind of remind me. Variable goes one way. Oh, wait a minute. I already have the variable alone and the constant alone. I don't even have to do that step. Sweet. Okay, so now I need to get x alone. So I divide by negative 5, divide by negative 5. Now in division, we don't change that sign. The reason why positive 2 becomes negative 2 is because add is and subtract are opposites. But divide and multiply are opposites, so it doesn't change that sign. All right, x equals 19 over negative 5. You can leave it like that. If it says, no, I want a mixed number, then you can make it a mixed number. If it's no, I want a decimal, then you can make it a decimal. But for algebra, you further and further you get in algebra, leaving it in this rational form is super acceptable, okay? Now, I'm going to take this negative. I'm going to show you that this is the same thing. A lot of times they'll put that negative right next to the fraction bar, and oops, and they won't actually attach it to the number, okay? So it'll look like that. Because only one of them was negative, that means that the overall thing will be negative. Okay, so you might see it like that, but they're basically the same thing. All right. So let's take a look at the next one. So I'm going to have my river. I do my parentheses. Nope, no parentheses. Yay. I'm going to do my likes. So I look here, no likes, no likes. Easy peasy. That step's easy. Cross it out. So I'm taking my variables to one side, and it's actually, I'm going to go the other way this time. But my constant, the important thing isn't that it's going left and then right. The important thing is that they're going opposite. So I'm going to take my variables to this side this time. Why is that? Because if I subtract, and I anticipate this, if I Then I subtract it from both sides, right? Because this is positive, that's going to be subtract. Cross that out, okay? I can see here that it's going to be a positive result. That's why. I want it to be a positive y. So I try to, when I do have to move that variable, I try to move it so that the result will be positive. It's not always like last problem, it was just easier to move it over and where it was already isolated, but that's just me. Okay, now because the variable went this way, so I'm going to go ahead and highlight that. That means that this has got to go this way. So we're going to do that. I'm going to try that again. That means that this constant needs to go this way. Okay. All right. So I had it pointing to the wrong thing. So plus 1 plus 1. See, even I make mistakes. So 7 equals 2y. Okay, so that was pretty straightforward. We've seen that. The big idea is that you brought the y to the right. The constant has to be to the left. Okay, so then I'm simply, here's the y. So guys, keep your eyes on that y because it's the number next to it that we have to get rid of it. I see some of you all like dividing by 7 on something like this. Now, find the y, divide by what's next to the y. In this case, it's 2. So we're going to divide by 2. Y equals 7 over 2. Done. If it asks for something different, give it. But why do extra steps if you don't have to? You're just going to make a mistake. You're going to do something silly like call that, like 3 or like 2.5 or something like that. Okay, so be super careful. And if you do have to change it, be super careful. But okay, so again, I'm going to highlight over here. This is going to be some of the bigger mistakes that people make. The smaller mistakes that people make are in the signs, but that's one of the bigger mistakes people make. Okay, so I'm going to go ahead and I'm going to do this last problem. Okay, so I've got my river now. So I've got the river, I've got the parentheses, and yes, I do have parentheses this time. So I'm going to go ahead and do those. 6 times 4 is 24 minus 6 times negative z. So can we do our 2 marks here? So we'll do plus. And then so 6 times negative 1. So if there's if it's empty there, it's got the invisible math. So we're going to make that a 1. So 6 times negative 1 is negative 6z equals 2z. So we did our parentheses. So now we need our likes. So we go here. Is there likes? No. Likes? No. And so the likes just go on each side of the river. So we'd have that. Not necessary. So now we get our variables to one side. I'm going to go ahead and go this way. And we can see here that the z is already isolated. So I'm going to go ahead and bring this z over here. So it's a minus 6z. So it's going to be plus 6z plus 6z. I'm going to get rid of this. I just underlined that for emphasis. Okay, so plus 6z. So it's a plus 2 and a plus 6. So we got 8z equals 24. Just double checking. I had a negative 6 and a positive 6, and they canceled. So that's good. Okay. So now I look at that z. I've got z right here. Awesome. Okay, so I've got times. So I'm going to divide by 8, divide by 8. Again, I look at the z and remove what's next to it. So I'm not doing any weird divide by 24 thing here. Okay, so z equals 3. And then that would be my answer here. And so you kind of get this sense that there is just really kind of once you get used to it, I didn't have to do the constants to the other side because they already were. And then I get my epsilon. Okay, so you kind of get this rhythm to it and get through those steps and just take it one thing at a time. Be super careful with those integers, and that's how we do this. So here are lesson 1.3, variables on both sides. I'm going to also attach a video going through some example problems from Get More Math and give you a chance to do some more practice on those. Okay, all right.